Hello, one and all. Welcome to TG Video Entry Number 1, aka my first ever YouTube video. And in this video, we are going to be doing decimal to binary conversion. So, what are decimals and binary numbers? So, we could start off with decimals. They are numbers such as 1, 2, 3, 4, 5, and so on. So they're just base 10 numbers that we all know and love. But what about binary numbers? Well, it's important to know that binary numbers are just represented with zeros and ones, meaning they are base 2 numbers. So they can be anything from the one I just drawed out, 0, 1, 1, 1, 0, 1, all ones, possibly, all zeros, and so on. So this gives you a basic idea of what they are. One thing to remember when converting decimals into binary is this chart right here, which is the place value holders. Each place value in binary represents a power of 2. So as you can see, 1 represents 2 to the power of 0, and 128 represents 2 to the power of 7. So remembering this will make your life a lot easier when converting decimals into binary. Let's start off by converting the number 35 into a binary number. So there are two ways we can convert 35 into a binary number, but we are going to do the division method first and then we're going to go to the next. So the division method, we just keep dividing 35 by 2 until our quotient hits 0. 35 divided by 2 is 17, and the remainder is 1. Then we want to divide 17 by 2, which is 8, and the remainder is 1. 8 divided by 2 is 4. The remainder is 0. 4 divided by 2, 2. Remainder 0. 2 divided by 2 is 1. Remainder 0. And finally, 1 divided by 2 is 0, and the remainder is 1. What we want to do from here is we want to write our remainders as one binary number. So we would start with the bottom since it is the most significant bit, and then we will write the top remainder last since that is the least significant bit. So we will write this out as 1, 0, 0, 0, 1, 1. And this would be our final answer right here. Now, we can check our answer to make sure our conversion was accurate. So how I would do it is I would write this as 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. Now, the ones that have the 1 bit, we could just simply add those together to make sure we get 35. Let's add them up. 2 to the power of 5 is 32. 2 to the power of 1 is just 2. And 2 to the power of 0 is just 1. Adding these up, 32, 2, and 1 would get us 35. And this tells us that our conversion was accurate. Now let's convert 52 to a binary number. So using the previous method, we could divide 52 by 2, and this would get us 26 with a remainder of 0. 26 divided by 2, 13, remainder 0. 13 divided by 2, well, that will simply get us 6 with a remainder of 1. 6 divided by 2, 3, remainder 0. 3 divided by 2 is 1, remainder 1. And 1 divided by 2 is 0 with a remainder of 1. Now that we have done this step, let's put all these remainders together from bottom to top as a binary number. So we will write it out as 1, 1, 0, 1, 0, 0. And this will be our final answer. Now let's check to make sure our conversion was accurate. I do want to mention that you can skip this step if you like, but this step is the way of making sure that we were on the right track. So 2 to the power of 5, 32. 2 to the power of 4, 16. And finally, 2 to the power of 2 is 4. 32 plus 16 plus 4 is 52, and this tells us that our conversion was correct. Let's do one more problem using the division method with 107. So 107 divided by 2 is 53 with a remainder of 1. 53 divided by 2, that would simply get us 26 with a remainder of 1. 26 divided by 2, 13 with a remainder of 0. 13 divided by 2 is 6 with a remainder of 1. 6 divided by 2 is 3 with a remainder of 0. 3 divided by 2 is 1 with a remainder of 1. And finally, 1 divided by 2 is 0 with a remainder of 1. Putting the remainders together from bottom to top, it would be 1, 1, 0, 1, 0, 1, 1. And this will be our final answer. Now let's check to make sure our conversion was accurate. As mentioned previously, you can skip this step if you like. So 2 to the power of 6 is 64. 2 to the power of 5 is 32. 2 to the power of 3 is 8. 2 to the power of 1 is 2. And 2 to the power of 0 is 1. Adding the numbers up together, doing mental math, would be 107, which means our conversion was accurate yet again. I never fail. Let's convert 39 to a binary number using a different method. How we can do this is we can refer to the chart below and look for the greatest number that isn't greater than 39. And doing so, that number would be 32, and then we would just simply subtract it from 39, which would be 7. So for reference, we could circle 32, since that was one of our numbers. And then we can look for a number that isn't greater than 7, but is the greatest one. And that number is 4. Subtracting 4 from 7 would be 3. So let's circle 4. And since we have just 3 left, we would use 2 and 1. The numbers that we didn't circle will be 0 bits, and the numbers that we did circle will be 1 bits. So I'm just going to write them above the chart. It would be 0, 0, 1, 0, 0, 1, 1, 1. And putting those together, it would be 1, 0, 0, 1, 1, 1. And this will be our final answer. Checking the accuracy of our conversion, 2 to the power of 5 would be 32. 2 to the power of 2 would be 4. 2 to the power of 1 is 2. And 2 to the power of 0 is just 1. Adding these numbers together, we would get 39, which means our conversion was correct. Okay then, let's convert the number 69 to a binary number. Nice. So, as previously, we want to refer to the chart down below and look for the greatest number that isn't greater than 69. And doing that number will be 64, and subtracting 64 from 69, that would get us 5. We want to do the same thing for 5 as well. Look for the greatest number that isn't greater than 5, and that number is 4. Subtracting 4 from 5 would get us 1. And since we just have 1 left, we could just simply circle 1 in the chart. Now, we can write zeros above the numbers that we didn't circle and ones above the numbers that we did circle. So it would be 0, 1, 0, 0, 0, 1, 0, 1. And putting that together, we will have the binary number 1, 0, 0, 0, 1, 0, 1. So this will be our final answer. Checking the accuracy of our conversion, 2 to the power of 6 is 64. 2 to the power of 2 is 4. 2 to the power of 0 is 1. Doing the mental math, you realize that would get you 69. So our conversion was correct yet again. Let's do one more problem. So we want to convert 165 to a binary number. And like in the previous two problems, we want to look for the greatest number that isn't greater than 165, and that number is 128. Subtracting 128 from 165, that gets us 37. Looking for the greatest number that isn't greater than 37, that's 32. Subtracting 32 from 37, that gets us 5. Then, greatest number that isn't greater than 5, 4. 5 minus 4 is 1. And then we just have 1 left, so we could just circle 1 in the chart. Writing the ones and zeros above the chart, it would be 1, 0, 1, 0, 0, 1, 0, 1. And writing this out as a binary number, it would be 1, 0, 1, 0, 0, 1, 0, 1. And this will be our final answer. Checking the accuracy of our conversion, 2 to the power of 7 is 128. 2 to the power of 5 is 32. 2 to the power of 2 is 4. 2 to the power of 0 is 1. Doing the mental math, that gets us 165. So our conversion was accurate. Okay then, that is going to be all for this video. It was a bit longer than I expected, but hey, It is what it is. And if you learned something from this or enjoyed it, feel free to like, subscribe, and hit that bell. And please let me know in the comment section what could be improved in future videos, or also other math topics or other topics in general you want to see from me. That is going to be all from me, and I will see you in the next one.